Hi guys, welcome back to my channel. Today we are going to be looking at hyperbola functions. So our learning goal is to describe, interpret and sketch hyperbola functions and their transformations. And today we're going to do that using tables, and we are going to have a look at transformations in the next video. So keep an eye out for that one. Okay, so a hyperbola is a graph or a function which has the parent formula of y is equal to 1 over x. So let's plot the graph of y is equal to 1 over x using a table. Okay, so first thing I'm going to do is I'm going to draw up my table. Now, if I'm not given a specific domain or a specific range of x values, I usually try to pick a couple of x values that are going to be on the negative side, so negative 1, 2, 3, and then I usually try and pick a couple of x values that are going to be above 0 as well, just to get a more balanced idea as to what's going on around the origin. Next, we're going to use FSA to find these values. So starting off, we're going to write our formula. So y is equal to 1 over x. We're going to substitute in our first value of x, which is negative 3. So y is equal to 1 over negative 3. And for our solution, we can leave it as a fraction if we want. I'm going to write out the decimal, and we'll use that recurring dot symbol just to represent that. So then we can go ahead and we can finish filling out the rest of that table using that method. So let's go ahead, let's do another example here. So our formula, y is equal to 1 over x. Substituting in y is equal to 1 over negative 2, because that's our next value for x. And so our solution, and again, I'm just going to do this as a decimal, is going to be negative 0.5. So we can go ahead and keep filling those tables out. All right, so if we do this formula one more time, y is equal to 1 over x. Substituting in our values, y is equal to 1 over 0. Now, for our solution, we cannot divide by 0. And I've explained this in the past, but basically it comes down to this idea that we actually, when we divide by 0, have an infinite number of answers. Or you can think of it as you have no answer or no solution. So what we were going to write for this answer here is we can just write that it is undefined. Okay, so I'm just going to use U to represent the fact that this is undefined, because we're not actually going to have a value of y at this particular value of x. So let's go ahead and let's fill out the rest of this table. Okay, so now that I've got my points, I'm going to jump over to Desmos and I'm going to pop these into a table, and I'm going to show you what this graph looks like. So this is going to be the beginning of my graph. So if we continue, I might add a few more values in just so we can see what the shape of this graph starts to look like. Okay, so now that I've added in a few more points, we can start to see what is going on with this graph. And so what we're starting to see is we're starting to see this line that almost looks like it's going to be curved here. Now, why don't we have any sort of values in this region here? Well, think about our formula and what's going on. So if I was to substitute in negative 1, remembering our formula is y is equal to 1 over x, this is going to give me a whole number. And as I increase the magnitude of these negative numbers, my formula value or my function value is going to get smaller and smaller and smaller. However, it's never actually going to touch this horizontal line. So for example, if I was to substitute in a very, very, very negative value, so let's say if we did x is equal to negative, say, 1,000,000, then we would actually have a very, 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 very small decimal. As I keep going up and I keep going towards negative infinity, then this is going to get closer and closer and closer to 0, but it's never actually going to reach 0. So we actually have a horizontal asymptote on this part of our function. If we think about what's going on over on this side, going and tending towards positive infinity now, the same thing is going to happen, except it will be a positive value, but very, very small. And it will always approach that horizontal axis, but it'll never quite reach it. Now, if we think about what's going on with this vertical axis going up here as well, so if you were to think these values here, so this is our value for 1, if we're looking at this positive value. So if we substitute in positive 1 into the function 1 over x, then we're just going to get 1 as our solution. So if we were to go back and if we were to divide by a fraction, then our numbers would start to get larger and larger and larger. And so we would actually start to see a vertical asymptote as well at these points. So this is the general shape of a hyperbola. So let's pop this function into Desmos, and then we can actually see what it's going to look like. So now that I've popped this function in, you can really see these vertical and horizontal asymptotes. And as I continue to scroll out here, you'll see that they become very, very close to zero. And it almost looks like they are touching zero, but they never do quite reach it. Because there is no number that we could divide into another number to get zero. We can only tend towards that value. So it doesn't actually ever reach. So we have this horizontal asymptote here, and we also have our vertical asymptotes. So these are really some of the key features defined by a hyperbola, and this is what's different to all the other functions that we've seen in the past. So these functions, these hyperbola functions, have two asymptotes. They have a horizontal asymptote and they have a vertical asymptote. So like any function, we can manipulate some of these values for our hyperbola. So this function here, we have y is equal to -3 over x. So this is going to be slightly different to our parent function. We could also make some other changes here if we wanted to do that, or we could also make some changes here if we wanted to do that, and that will cause the graph to change. But let's go ahead and let's solve this question here, and we're going to do this using our table again. So plot the graph of y is equal to -3 over x for the domain -4 to +4. So let's pop our tables in. So now that we've got our table of values, let's go ahead and use FSA. So our formula is going to be y is equal to -3 over x. Our first value of x that we're going to substitute in is x is equal to -4. So -3 divided by -4. And our answer is going to be y is equal to 0.75. So we would go ahead and we would pop that into our table here. Okay, so our second question here now, and I wonder if you can see what's going to start happening with some of these transformations already just by manipulating this top value. Okay, so our first formula we're going to start off with is -3 over x. Substituting in this second value here, so x is equal to -3, so -3 divided by -3, and our answer is going to be y is equal to 1. And we would keep going, and let's keep repeating this, and I'll finish filling out the rest of this table. So just like the last graph, when we have x is equal to 0, we have an undefined value at this particular point. So with these values here, we can see we start off with 0.75, and this is increasing and increasing and increasing and increasing. And then we reach that asymptote where this is undefined, and then we begin at the opposite end, and we begin becoming more and more negative. So let's go ahead and plot this into Desmos using our table. All right, so we have our line that's in black here, and this is our parent function, so y is equal to 1 over x. And this function here was that table of values that we've created from y is equal to -3 over x. So I'm guessing we're starting to see what's happening with some of these transformations here. So the first thing I want you to observe, looking at the distance here between the function and between the axes. So this function, y is equal to 1 over x, is a lot closer to those axes compared to the graphs of y is equal to -3 over x. The other thing that I've also noticed with -3 over x is this is flipped these axes values here. So those are just a couple of observations that I'm noting just by looking at the functions of these graphs. So that's how we use tables to plot these general functions or these hyperbolas. So in the next video, what I really want to start doing is I really want to have a good look at what some of these transformations are. So rather than having to plot from a table all the time, then we can just look at the function and we can graph straight from the function. I've probably mentioned this in a few videos before. I think it's a lot easier when we know the transformations because then we don't have to go the long way about things. And that's the thing with maths. The harder it becomes, the more shortcuts that we start to look for because we want to make things easier for ourselves. And the mark of a good mathematician is somebody who can take something really quite complex and simplify it in some way. So in the next video, that's what we're going to have a look at. We're going to be looking at transformations of this graph. So please keep an eye out for that one. Have a good day. Bye, guys.